M1 Statics Example 3. In this example, we've got quite a complicated set of forces to resolve. It's very similar to the previous examples. I know that coming up partway through this question, there is a little bit of a tricky bit to the algebra, and you need to know a fact about trigonometry that if you haven't studied C2 yet, you might not know. So I'll just tell you that fact to start with, and maybe you can spot during our working out how I'm going to use it. So there's something that is always true for any angle, and that is that if you do sine of x divided by cos of x, you always get the same answer as if you did tan of x. Now, because it's always equal for every value, we actually put 3 lines and we call it an identity, something that is always true no matter what value of x you choose. So you could try that on your calculator and see if you believe me. So that's something that you cover in C2, and it's a fact that we need to know for this question. So, because we have an incline here, an incline plane, if you remember from dynamics, we always resolve along the plane and perpendicular to the plane. And we're going to do the same thing here. So I'm going to go along the plane first. So I'll draw a little diagonal arrow to show which direction I'm going. So going up the plane, well, we need to consider each force, don't we? So we've got this P here would have a component up the plane, and that would be P cos of alpha up the plane. There's an 8 newtons acting the opposite way, and then we mustn't forget that the weight of this particle would also have a component down the plane. Now we know that this angle here will be 30, so it's the same as that angle at the bottom. And so down the plane we've also got 5 sine 30. So I'm doing up the plane equal to down the plane. Okay. Now, if we do the same thing but perpendicular to the plane, the 2 is acting vertically upwards. We've also got a component of P that acts upwards. That's P sine of alpha. And then if you look perpendicularly downwards, you can see that this 5 would have a component, and that would be 5 cos of 30. So we've got 2 equations, and unfortunately they both have 2 unknowns, so it's definitely simultaneous equations, but these are unusual simultaneous equations because they've got trigonometry in them, which is something we haven't come across before. So I'll teach you a little trick as to how we go about it. The first one's got P cos alpha at the front. I'm going to rearrange this second one here so that it's got P sine alpha at the front. So that's 5 cos 30 minus 2. And I'm going to call these equation 1 and equation 2. Now remember, sine over cos equals tan. So I'm going to look at this sine, look at this cos, and I'm going to do equation 2 divided by equation 1. Now you might be able to spot why I'm doing that. I'll write them out in full so that you can see what's happening. So on the left hand side, equation 2 has P sine alpha, and equation 1 has P cos alpha on the left hand side. On the right hand side, equation 2 is 5 cos 30 minus 2, and equation 1 is 8 plus 5 sine of 30. Now, why have I done this? Well, I've done it because I know that the p's here, because there's a p on the top and the p on the bottom, they will cancel out. And I also know that sine divided by cos equals tan. So this left-hand side, we've eliminated the p's, and we've just got tan alpha equals all of this. How do you then work out what alpha is? Well, alpha would then be inverse tan of 5 cos 30 minus 2 divided by 8 plus 5 sine 30. Work that out on your calculator. Make sure that you set in degrees, sorry, not in radians, and I got 12.5 degrees when I did it. Again, make sure you keep that full angle in your calculator, because what we're going to do now is we're going to substitute it back into either equation 1 or equation 2. Doesn't matter which you choose. So if I choose equation 1, we've got P cos of 12.5 keep the full value, equals 8 plus 5 sine 30. And so by dividing by cos 12.5, we'll get P is 8 plus 5 sine 30 divided by cos of the full value 12.5. And if you type all of that into your calculator, I think it works out to be 10.8 newtons, because P is a force, so that would be measured in newtons. So that's a new trick there that you perhaps wouldn't have spotted to do, but maybe in the future you might spot it. If you've got something in terms of sine and something in terms of cos, actually dividing the two equations, one by the other, the one with the sine goes on the top, the one with the cos goes on the bottom. The p's cancel out nicely and we get tan alpha is equal to a particular value, and then we can work out what alpha is. So that's a little technique to remember for the future.